Greetings, radio people. Welcome once more deep to the bowels of LAM Communications, where we find ourselves once more in Lamco Labs, where there is much excitement afoot due to the fact that we have this very exciting box of tricks to play with. This is a magnetic loop antenna designed primarily for the FT817 or FT818, but it'll work with any rig in a QRP way, and is also an excellent receive antenna. The kit comes with a loop of helix type coax. There's a tuning box of tricks and a tripod to go with it. This is the antenna tuning part, this is the tripod, and then there's the cable for connecting it to the radio. So I'm going to put all this together, stick it on the bench, and let's take a look at it. So I've assembled this antenna bob. We have a tripod here, we have the tuning box mounts on the tripod, and then we've got this very stiff heliaxial type of coax which is very rigid and supports itself quite firmly. Then the feeder cable connects into this box of tricks here, and then clearly the other end of this would go to your rig. Now, if you were using this on top of a hill or out portable somewhere, or even in the shack like I'm doing, the easiest way to tune it would be to simply tune for maximum noise on receive. So you just keep fiddling with the controls until you got maximum receive noise, and then you're likely to be close to the resonant point. But what I've done is connected up to a return loss bridge and my spectrum analyzer, so we can really have a look at some detail of how this thing actually works. So let's have a look at that. So what you're looking at now is my Regal spectrum analyzer with a return loss bridge connected. That's what this lump here is, and this allows us to measure return loss. So the higher the return loss, the lower the SWR basically. Now I've put three markers on the screen. There's one on the left is at 7 megahertz, the one in the middle is 14, and the one on the right is 21 megahertz. So by altering the controls on the antenna, you can see that I can move the resonant point of the antenna. Now if I adjust it quite carefully, I can now get the SWR on 40 meters down to about 1.3 to 1 or thereabouts. So that's perfectly acceptable for 40 meters for transmitting. Now by altering the controls, so let's now try and tune it up on 20 meters for example. So what I need to do is keep moving the peak around until I find the kind of the maximum peak, if you like, around where I'm looking for. So let me keep adjusting the controls and see if I can find it. I'm very close now. And there's the phone. So that's pretty much where we need it to be now for 14 megahertz. They're quite tetchy, the controls, you have to fiddle with them a bit, but the SWR now on 14 megahertz is quite low. So that's down to 1.6 to 1, so I could just keep tweaking it a little bit and we get it a bit lower. There you go. So that's now down to 1.5 to 1. So that again is perfectly acceptable, but you would be able to do that pretty much with something like an FT817 or 818 by peaking the receive noise. Let's have a go at see if we can move the point up to, well, that was very easy, just altered one of the controls. The resonant point is now up around 21 megahertz. The second control seems to alter the sharpness of the resonance. So you make it nice and sharp and then tune in on the frequency that we're looking for. And there we've now managed to adjust the SWR on 21 megahertz down to 1.5 to 1. So this seems really quite easy to span from 40 meters up. It would be excellent as a receive antenna as well, because clearly you can peak it anywhere you like, not just on the amateur bands. This is working much like a mag loop as I'd expect it to. They tend to have quite a narrow SWR bandwidth, if you like, but by altering the controls you can pretty much set it up to be resonant wherever you want it to be. I like the look of this a whole bunch. What do you think?